We have the word Shopify. Shh. Whenever I give you a word, you are going to assume that you cannot repeat unless repeated letters exist. Like pool has 2 O's. Then you could have 2 O's because pool has 2 O's. That's it. You couldn't have an unlimited amount of O's, right? When I give you a word, it is Scrabble tiles. It's like you literally have that many Scrabble tiles, so it's always box and hold. Whenever you have a word, it's never any different. I specifically did A, B, and C to see if you guys read, because that's going to be the downfall of most of you is reading thoroughly. So here it says, we have the word Shopify. How many 3-letter words? So this time I'm just asking you to make 3-letter words, so that's 3 blanks. Make sure your phones are away. 1, 2, 3. How many letters are in Shopify?
Are you Oh.
Gotcha. So, we start with how many letters? 7, then?
6.
Then? Because we go down by 1 each time, because it is a word. So don't call me over and be like, can I repeat? If it's a word, I'm going to say, when you ask a question, I'm just going to say, it's a word. And then you're going to look at me mad. But that's all I'm going to reply to you. It's a word. Because if it's a word, you have what you have on Scrabble tiles. Okay? 765 is what? Pardon? 210? Then the next one says, using all of the letters. So using all the letters, how many words begin with a consonant and in a vowel? So we're using all of the letters. All of them. We want to make a word with all of the letters. So how many letters do we have? 1, 2, 3, 4, 5, 6, 7. Now I want to begin with a consonant and in a vowel. So for consonants, I have S, H, P, F, Y. And then for vowels, I have O and I. Okay, so I want to begin with a consonant. So if I want to show all my work below, I can. So I have S, H, P, F, Y. I'm so glad I pressed blue because it's still doing black. All right, so I have 5 options. Say I hold the S. Cool. Then I have to end in a vowel. So O or I. So that's 2. Say I hold the I. Now I have used up the S and the I. So I've used up 2 out of 7, correct? So how many do I have left for this blank now? 5. If you don't see that, rewrite out what you have left. OHP FY, which is 5. Hold the Y, then I would OHPF, which is 4. Hold the F, I would have OHP, which is 3, then 2, then 1. So you see how you're holding letters as you're going along, right? So that should be 1200. 120 times 10. Okay, using all the letters, how many words begin and end in a vowel? So now I have to begin and end in a vowel. So I have O or I as my option. Just 2, say I hold the O, or the I, sorry. And I have O, which is 1. Now I've used up the I and the O. How many letters do I have left for the middle? 5, then 4, 3, 2, 1, which is 240. Now the last one, I keep asking the same thing over, and people still don't know how to do it. So remember that you write notes for a reason. So you guys can, all of you can go to the example in your notes and look it up, right? If you're stuck, that's the reason why we do notes, is so we can look at them. You can ask me too, but please try and use your notes, because then you know what's in your notes, right? Because you have an open book test next week. You might as well at least know what's in your notes and where it is so you can find it. Hopefully you don't need your notes, but at least you'll know you have them. So how many odd? Odd means I have to end in an odd number, right? 6 digits means I have what? How many blanks? 6. And the first one can't be a what? 0, because it's a 6-digit number. That would be a 5-digit number. If it was a 6-digit code, could I start with a 0? Codes, yes. Numbers, no. Okay? So here I have 1, 3, 5, 7, 9, which is how many options? 5. And then it says I can't repeat. So I'm going to hold one of them. I'll hold the 9. Then I have 1 to 8. I can't use 0 because this would be a 5-digit number then. So that's 8 options. So I hold the 8. Now some people will say I only have 1 to 7, which is 7 options. But you don't have 1 to 7, you have 0 to 7, which is 8 options. Hold the 7, 0 to 6 is 7. Hold the 6, 0 to 5 Okay, 6, and then 5. Do I need to show the work below the blanks to get full marks? No, that is to help you, okay? I'm showing the work to help you. But if you do it without the work because you can do it now, you practice it enough without the work, this I do not have to see. I like seeing it. I don't have to. I do have to see the top numbers with multiplication dots, right? So make sure you have multiplication dots. If you're an avid not multiplication dotter, go back and put your multiplication dots in. So what is the answer to this one? What do we get? Just read out the number. 1,200? Just go 1. Guys, no one has it?
67,200.
Yes? No? Maybe so? Okay, we have 2 nods. I'm going to take that as everyone agrees. With the two nods means all. Okay, we're going to flip back to our notes, please. Okay, this one says, Isla has downloaded 10 new songs from an online music store. That's my daughter's. Don't cut down how it's spelled. I did not foresee the fact that the capital I would look like a lowercase l in all fonts and that she would get called Lila. Or, if they use the capital I, she would be called Ilya, because they swapped the Y and the L in their heads. So,
No, because you said daughter.
yeah, that's what I did see. See, that looks like Isla, if they just do capital I's like a normal human. They don't. So then when I had my second child, I spelt it like this, like England, and now they want to put Y's in it. I'm like, can't, there's no winning. Like I spelled London, like London. They're like, how do you spell that? Like London. Okay, and they put some Y's.
How do you spell London with Y?
Londyn.
Keep that with that.
Yeah. Okay. Isla has downloaded 10 new songs from an online music store. She wants to create a playlist. If she wants to create a playlist, does order matter if it's a playlist that's not on, like, random?
Yeah.
No. Order does matter. It doesn't matter if it's on, like, random. But if it's a playlist, it does matter. You have to go in the order of your playlist. Unless you put it on, what's it called? Blanking. Shuffle. Yeah. That's real. That's been shuffled for a lot of years, but my brain wasn't coming up with the word
That's
shuffle.
a hard word.
You know, you guys can't answer like 672, but guys, you know when it's like randomly and the word shuffle, the whole class. Miss, thank you. Thank you very much. See, you guys can speak. It's real. Other than Nolan. She wants to create a playlist using 6 of these songs arranged in any order. How many different songs, 6-song playlists can be created? So we want to actually make a playlist. We want it in an order that we could see it, correct? The moment you do blanks like this, you are literally giving something order. So if I go, not this blank, that would be the first song in the playlist, second, third, fourth, fifth, sixth. If it's on random, I wouldn't do blanks. If it was random, I wouldn't do blanks because I'm giving it a specific order, right? We're paying attention? So, in the first blank, how many songs do I have? How many options?
6.
No. My goodness. 10. That was a very unison. There's a lot of, the only answer was 6 from everyone, so that's good. You all agreed?
I would I said 10. That's very close.
You what?
I said 10.
Okay.
He did.
He did. Okay, 10 then? 9. If you say 10, then 10, then 10, then 10, you are literally listening to the same song over and over. That's awful. That's not a playlist. So 10, then 9.
8.
8. 7. 6. 5. We can all count down. We're winning. Okay, type it into your calculator.
15120.
That?
No, I'm not gonna do
Really?
that. Yeah.
Been there the whole time. I don't know what you're talking about. Okay. Ready. Paying attention up here. Make sure no phones are out. 9 girls are available to fill 3 positions on a hockey team. Center, winger, and defense. If you're picked first, you're center. If you're picked second, you're winger. If you're picked third, you're defense. Okay? Does order matter? Yes, you have specific jobs. Order matters. So we're going to draw lines. Whenever we're arranging something or giving it order, we draw lines. So our first line would be the position for center. Person who gets picked for center. And I need to pick someone for winger. And I need to pick someone for defense. Now here it says 9 girls are available to fill 3 positions, center, winger, and defense. If all girls are equally competent in each position, which is not really true, but we're using it anyways, how many different ways can the positions be filled? So, how many people do we have for center then? 9. Then 9 and 9? No, what do I have to do? I have to do 8 then 7, but why?
Because you can't like clone.
You can't clone the human to be getting all 3 positions, exactly. So 9, someone becomes center. 8, someone becomes winger. 7, someone becomes defense. And what does that equal? 504? All right. No, we're not done learning. Okay. Here we have, at a used car lot, 7 different car models are to be parked close to the street for easy viewing. So it's 7 different looking cars. Even if they were all in the exact same blue, could you tell them apart? One is like a Ford Mustang and one is a Ford Focus. Yes, you can tell them apart. Okay? They're different models, even if they were painted in the exact same blue. Okay? Here it says, the 3 red cars must be parked so that there is a red car at each end and a 3rd red car exactly in the middle. How many ways can the 7 cars be parked? So I'm parking them in a row, correct? So could I not just draw 7 blanks side by side by side and visualize the 7 cars in a row? Yes. So I go 1, 2, 3, 4, 5, 6, 7. Boom, 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 boom. Now I know that they're all 3 red, but we've discussed this already. Can I tell them apart, or are they all the exact same car? You can tell them apart, because even if they're all painted in the exact same red, they look different, right? For example, one could be a minivan and one could be like a Ford F-150 truck. Perfectly the exact same red. Obviously, you can't tell them apart. Obviously, you can, right? Like you can tell them apart, but they're all in the same red. So, we have to park one at the front, one at the very back, and one in the middle. So, we have to start somewhere. I'm going to start at the front because I like starting at the front. And I like also going in sequential order of which they listed it. But that's just personal preference. So, how many red cars do I have to park here? 3. Then I still have 3 to park here? No. What did I need to do here? I have, Nolan, I have 3 cars.
You will make me forget what number I was on. Thank you.
Oh boy. Okay, I have 3 cars at the front, but then I do what with that car? I park one. Because this means I park 1 car. Remember, I can put one object in that blank? So yes, I have 3 options, but I park 1. Then I go to the back, and I park 1, but how many options do I have?
2.
2. Park 1 of the cars. Then I go to the middle, and I have how many options of red cars left? 1. Now, does it matter if I started in the middle, then there? No, I would just have 3 here, 2, 1. They would just be in different spots, but when you multiply, does the order matter in multiplication? Like 2 times 3 is a difference than 3 times 2? No, so we could have started in any of the 3 spots, but we'd still have to go down by 1 number. Okay, how many cars did I park? 3. In each of those spaces, I parked a car. So how many cars do I have left? 4. And I always just go from the left to right if there's no other restrictions. So there's 4 cars for this one, then 3, then. And when you multiply them out, what do you get? Okay, so we're going to have to use a lot of brain matter. Paying attention? All right. This one says the 3 cars must be parked side by side. Does it say at the front? Does it say on the left? Does it say at the end with all 3 parked side by side? No, it just says they have to be parked side by side. Okay? So I'm still going to park 7 cars. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Now I'm parking the 3 cars side by side. We agree? So what I do is I park them side by side all at the front, and then I'll move them around after. But I'm going to start with them all together at the front. So I'm going to hook them together because they need to be parked side by side. Do you agree? Okay. They need to be parked side by side. How many options would I have for this first blank? 3. Then I park a car. So how many do I have next for this blank? Then I park a car, then? Okay. How many cars do I have left? 4. Park a car. 3. Park a car. 2. Park a car. 1. That would be the answer if they all had to be together on the left. Correct? Did it say all together on the left? No, so I actually have to show all the cases in which it can move, but they would still be all together. Pencils down, paying attention. Okay, you're not writing this, you're just paying attention, okay? If you don't pay attention, you will never get this, it will be bad. So, I have 3, 2, 1 with the red cars together, and then 4 other random cars parked in a line. We agree? And this is the red cars together. This is one way the red cars could be together, correct? Or I could have another way the red cars could be together. I could actually pick up all 3 red cars and put them between the 4 and the 3. Could I not? Would it look totally different? Yeah, I'd have 1 car, all the little red cars, and then 3 other cars. So that's another option I could do. I could go 4, and then 3, 2, 1. And then I would have 3, 2, 1 left over. Then I could take all 3 of these cars and I could put them between the 3 and the 2 car, right? So I could go 4, 3, 3, 2, 1, 2, 1. Then I could put them between the 2, 1. 4, 3, 2, 3, 2, 1, and 1. Or I could just completely pick them all up and put them at the very right-hand side. They'd still be together, correct? But it would look different. How many different cases did I just make? 5. With the same number, right? If I went 3 times 2 times 1 times 4 times 3 times 2 times 1, or I went 4 times 3 times 2 times 1 times 3 times 2 times 1, I get the same answer. Because it's just multiplication out of order, correct? So instead of showing 5 cases, what I could do then, pick your pencil back up, what I could do is just multiply this by 5. Now people get stuck with not knowing what to multiply it by. If it says together, you can always multiply it by 1 more than the number after the hooked together numbers. So you see the hooked together numbers, the number after it is a 4. So we're going to multiply by 5. Because there's always going to be 1 more space than the numbers that are behind it. So I have 1 space where they stay here, 2, 3, 4, 5, right? This would be 1, 2, 3, 4, 5. So it's always 1 more space than that number. So you always times by 5. There's always 5 cases if it's a 4. So what's, that would be 720. Caveat. Now I have 9 cars. 4 are blue. How many ways can the blue cars be together? Try this out. I want the blue cars together. 9 cars we're parking. So how many blanks do we have? 9. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many am I parking together? 4. Boom. 4, 3, 2, 1. Right? How many cars do we have left to park? 5. 5, 4, 3, 2, 1. Are we done? No. This would be correct if I said blue cars parked together on the left or blue cars parked together on the front. I'd be done, right? There'd be no other way for me to go. I would be done. But I just said blue cars parked together. So we have to count all the cases of ways that they could be parked together. So let's think about it. My hand is the 5 cars. We agree? These 5 cars over here that are not hooked together. Does everyone agree with that? Yeah. So here are the 5 cars. So those 4 cars could be parked here, which is 1 way. Or I could pick them up and park it here, which would be a totally different look, which is 2. Or here, which is 3. Here, which is 4. Here, which is 5. Or at the complete back, which is 6. So you actually have to multiply by 6. If that makes no sense, you could also just memorize it's one more than this number. So here's the hooked together numbers. The number after it is the number 5, and then multiply by 6. I'd rather you not memorize, but if that's what you have to, we'll go with it. So this is the same as 4 factorial times 6 factorial. And then I get people going, whoa, 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 that's 4 factorial times 5 factorial times 6. Same thing. 4, 3, 2, 1, blast off is 4 factorial. We agree? Could I technically move this 6 in front of this whole 5 dealio and go 6, 5, 4, 3, 2, 1, blast off? Yeah, I could rearrange them. So that's why I can say 6 factorial. And I don't have to say 4 factorial times 5 factorial times 6. What do you get as an answer for this one? 17,280?
Yeah. See, I can do math. I'm not so confident.
It's really good if you could actually complete some like, I'm not even believing that that's done yet. So,
But
Unit 1, Task 1.
it's not good start. You're right.
Example 7. A social insurance number, a SIN in Canada, consists of a 9-digit number that uses the digits 0 to 9. If there are no restrictions on the digits selected for each position in the number, how many SINs can be created if each digit can be repeated? Then it says, how does this compare with the number of SINs that can be created if no repetition is allowed and it must start with a 6? So let's do the 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. No restrictions. So what would each of these have then? How many options would each of these have if there was no restrictions? 10. Because it is a 9-digit number and as it is a code, they would say that the first digit could be 0. They'd have to specify that, or it kind of throws before using the word number. Now, this would be 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. 1 with 9 zeros. Should be 1 billion, correct? How does that compare if I limit it now to no repetition and it has to start with a 6? Try it out. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one has only the option 6, which is how many options? 1. Then I box and hold it. So then how many do I have for here? 9, 8, 7, 6, 5, 4, 3, 2, 1. So technically I could just type in 9 factorial, which is something of which I'm going to look at it. What is the answer? You can just give me numbers.
3,880.
What?
362,880.
You guys got to like one spot and then overlapped each other, and then it just got real confusing.
This is Mark's fault.
You're being recorded, just so you know. All right. Look here at the your turns. You're doing these. A, B, C, D. Look at it. Number 2. You're doing this. Flip over. Pass this. And number 3, get working. And then we're moving on to permutations with restrictions and repetition. So I'm giving you maybe 5 to 10 maximum minutes, probably 5. Golden is how many letters? Does it have to say that they can't repeat? No, because it is a word, and words are Scrabble tiles. That's 1 G, 1 O, 1 L, 1 D, 1 E, 1 N. So I have 6 for this one then. 5, which is 30. 3 letters from chapters. How many letters are in chapters? 8. So it'd be 8, 7, 6, which is 360? 336? Okay, 4 letters from wealth. 1, 2, 3, 4. There's 6 letters, so it's 6, 5, 4, 3. Which is how many? Yep. And then 1 letter from value. 5. The next one says, in a 10-team basketball league, each team plays every other team twice. 1 home and 1 away. So there's 2 teams playing at a time, right? So I do 2 blanks. We agree? How many teams can be in the home team? 10. How many can be in the away? Some people tell me 10. That is the craziest basketball game. You're playing yourself. 9. It can't be 10 and 10 because you would have no person to play, right? You could say, well, I can play myself. That's not true. You're playing every other team. So that would get me 90. But that's them playing home and away and playing once. So what am I going to have to do? That's what I thought.
So every other team.
No, that's not what that means. It means every other team, like every other team but you.
Oh.
Yes. So it would end up just actually being 90. This counts into account home and away.
Oh. You're wrong.
So you don't times it by 2. If it C's, you times it by 2, but we're counting home and away, so it makes a difference. Okay. In a competition on the back of a cereal packet, 7 desirable qualities for a kitchen, example, spaciousness, versatility, etc., must be placed in order of importance. If I'm placing it in order, I can look at it. So I draw lines. The number of different entries that must be completed in order to ensure a winner. How many different versatilities could be here, or how many different qualities could be here? 7, then 7 again. Could it be like versatility, 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 like that's excessive? No, it would be 7 then 6, because I would leave one of the desirable qualities behind, right? 5, 4, 3, 2, 1, which is 7 factorial, which is 5,040, I believe. Okay. So, up until now, I have not given you anything that has repetition. So every word I've given you, you haven't maybe noticed, but there's no doubling or tripling letters in any word I've given you to this point. I've given you no repetition whatsoever. So what happens when I do? So let's look here. Consider the stuffy example from the last lesson. So I showed it to you. There were 6 ways to arrange the stuffies. What would happen if instead of 3 different stuffies, we had 2 of the exact same kitten and 1 puppy? How would this affect your answer of 6? So we had 2 kittens and 1 puppy instead. So I go kitten, kitten, puppy, right? Okay, now I swap the kittens. Kitten, kitten, puppy. Does it look any different? No, so that case is out. Okay, what about kitten, puppy, kitten? Okay, cool. Now I'm going to swap the kittens. Kitten, puppy, kitten. Does that look any different? No, it kicks that one out. And then puppy, kitten, kitten. That looks different. Okay, now I'm going to swap the kittens. Does that look different? No, so instead of 6, there's actually 3. Well, how the heck can we do that? Well, when we talked about them all looking different, it was a puppy, kitten, and a bunny. We were lining them up in a row. When it was puppy, kitten, bunny, we had puppy, kitten, bunny, so we had 3. And say we laid the puppy there, then 2, then 1. We had 6, right? True? Well, now we have half as many. Well, there's got to be a better way than listing out all the examples and crossing off the ones that match, because that would be awful if it's 1,000 cases. So what do we do when we have repetition? We just do the top like normal. So I would do it as if they were all different. So the puppy, kitten, and bunny, I'd say, oh, I have 3 objects, then 2, then 1. But all I do is I divide by factorial the double ups or triple ups. So I happen to have 2 kittens, correct? So I'm going to divide by 2 factorial down here. And then my answer is actually 3, which is the correct answer for this one. So you end up dividing by factorial the doubling or tripling up of things, objects. Obviously, we're going to do more examples. So, this one says, in the mountainous regions of India, China, Nepal, and Bhutan, it is common to see prayer flags. Each flag has a prayer written on it, and color is used to symbolize different elements: green water, yellow earth, white air, wind, blue sky, space, and red fire. How many different arrangements of the same prayer can you make using all 9 flags? So I'm giving you 1 green, 1 yellow, 2 white, 3 blue, and 2 red. So we treat the top as if they're all different. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many flags do I have? Make sure you're paying attention and not talking. So how many flags do I have? I have 9. So do I have an unlimited amount of flags, or do I have just 9? I have just 9. So this would be 9 flags. Then I leave a flag behind then. 8 then. I can wait. 7 then. 6, 5, 4, 3, 2, 1. Now that would be the answer if they all looked different. We agree? However, there's 2 white. So wherever the white are the same and I say I flip them and it makes something different, does it actually? No. Wherever the 3 blue exist, if I swap the 3 blue around but they're in the same positions, does it change how it looks? No, it would still be blue, something, something blue, something, something blue, right? It wouldn't change it. So what do we always have to do when we have repetitions? We just take these repetitions, we treat the top like they aren't repeating, so I didn't. I treated the top like they were all different. And then all I do is I divide by the factorials on the bottom and it gets rid of all the cases where they are the same. So I divide by 2 factorial for the 2 white, 3 factorial for the 3 blue, and 2 factorial for the 2 red. Everyone grab out their calculators, because different calculators do this differently. Follow along. So if you have the TI-83s, there's no fraction button you're ever getting. If you have the TI-84s and above, you can get a fraction button. So let's start with the ones that have color. So the ones that you have to charge that have color, you guys are following me, because you're the same as this calculator. So what I would ask you to do is always do the fraction. So if you have the ones who plug in, you guys can do this. You can go alpha link, and a fraction should pop up. Alpha and the button beside it. So everyone with the charging ones, does everyone get the fraction to pop up? You go alpha, link, the one beside it. Do you have the fraction popping up? That is not that. Nope. So it's the charging ones. So then you would go, everyone, if you have this, then you would just do n, guys, stop. N factorial. That is not factorial. We do 9 factorial divided by 2 factorial, which could you write as 2, 3 factorial, 2 factorial. And you got that. If you have the TI-83, 84 pluses, the only thing not the TI-83s, the TI-84 plus, you can get a fraction as well, just not the same way. So what you can do is you can go alpha y equals enter. So if you have the TI-83s, you do not have a fraction button. Nowhere in there are you going to find one. If the colored ones, you can go alpha link. If you have the TI-84s, you have to go alpha y equals enter, and you're going to type it in now if you have the TI-84s. If you have a TI-83, you can still do it, but watch this. If you're the TI-83s, please watch me. If you have a TI-83. If you do this, because you don't have a fraction button, watch. Does it give me the same answer? No, because what your calculator is doing is order of operations. So it's going 9 divided by this, this, this. So watch. If you have the TI-83s, there are things you can do. I want to bring that one back. And if you have the newer calculators, you could just arrow up and steal it back, right? If you have the TI-83s, I can bring this back and add brackets to it. So I can go second entry. So second enter, and it'll bring it back. So even if you don't have a TI-84, you can bring back your previous stuff. You just go second entry and you bring it back. And then you go second insert and you put in a bracket. And you guys can insert brackets anytime you want, or insert other things. Then I have to put brackets around that whole denominator so that it does know it's a fraction. And then I get the right answer. So if you choose not to use the fraction button or you have a TI-83, you have to make sure you put your brackets around the denominator. Yeah. Yes. So 15,120 is my answer. So we're going to look at some words here. Determine the number of permutations in the word Vancouver. Everyone, when you get a word from now on, you are going to rewrite out the word every single time. It's going to be your very first step. So I'm going to go V-A-N-C-O-U, and then I double up if there's doubles. So I stack the V-E-R. I didn't stack anything else because nothing else doubles or triples. The reason why you draw the stacking is for twofold. One, so you don't miss some things that are doubled up. And two, you stack it and then you're like, oh, right, I need to divide by factorial. So it gives you a little reminder. So immediately, before I even do the numerator, the denominator is going to have a 2 factorial on it. Before I even do the numerator, the denominator is going to have a 2 factorial because of the 2 B's. Vancouver has 2, 4, 6, 8, 9 letters. So the top, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 blanks. Are there any restrictions of like starting with a consonant, ending with a vowel, or anything like that? No. So I pretend that the letters are all different. Remember, I pretended that I could tell the B's apart because this 2 factorial gets rid of all the cases where I can't. It fixes the problem. So how many letter options do I have for this first blank? 9 then, 8 then, 5, 4, 3, 2, 1. So if it is just the word without restrictions, you can just do the factorial of all the letters over 2 factorial. So I'm going to type that in. Then enter. Oh, you might have a fake TI.
Uh-oh.
Yeah, yours is a TI-83 that pretends that it's
That's a thing? Oh, maybe I got one of those. Oh, wait, do I have one of those?
probably. There's like a little spell of them that came out that if your phone doesn't pop up, there's the TI-83 and a TI-84 body. Rude. What do we get for this?
Mine's also 3911.
What do we get? 440? Okay, everyone's trying mathematical. Mathematical. M-A, guys quiet, we just have this get through. M-A-T-H-E, M-A, M-A-T-I-C-A-L. So I know before I even go to do the question, I'm going to have 2 factorial, 3 factorial, 2 factorial on the bottom. Not 7, because I have 2 and then 3 and then 2. If you say 7, you have 7 of the same letter, which some people do. If you go 2 times 3 factorial times 2, that's actually 24. And 7 factorial is 5,040. So you don't want to divide by putting them all together. Mathematical is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters. So you go 12 factorial over top. Did someone get the answer? 400? Okay. Shh. We're going through this because we have a different one tomorrow. It's the last thing we're going to end with. Determine the number of different arrangements of the 6 letters in the word answer. So I always rewrite them because now I've learned there can be doublings. So I go A-N-S-W-E-R. If I just end up rewriting the word, that means I have no denominator, right? That just means I have no doubling or triplings. So without restrictions, I would still have my 6 blanks. I'd have 6, 5, 4, 3, 2, 1, because I box and hold because it is as a word. 6 factorial is 720. 5,040 is 7 factorial. Begins with an S. 1, 2, 3, 4, 5, 6. I have to begin with an S. There is one S. If there was 2, I put 2. And then 5, 4, 3, 2, 1, which is 5 factorial, which is 120. And then I have begins with a vowel and ends in a consonant. So vowels I have are A and E. So I have 2 options, hold 1. Consonants are N, S, W, R. So I have 4. Hold one of those. How many letters have I used up? 2. So how many do I have left? 4, 3, 2, 1. Which is One, what?
I'm gonna do two.
And that's it. Tomorrow we finish this lesson and then you guys have homework to work on.